Hello students, welcome to the third lecture of third unit HDTV. In last lecture we have seen the concept of HDTV, that is definition of HDTV, what is actually the HDTV and how the HDTV works, that also we have seen. We have seen the transmitter and receiver block diagram related to the HDTV and working of each and every block present in the transmitter and receiver of the HDTV in the last lecture. Again we have seen different standards and different systems they are related to the HDTV. In this lecture now we will see digital TV satellite system in details. Okay, let's start the point. The satellite system. A satellite system is any body that moves around another one in a mathematically predictable path, that is called as a orbit, or we can call it as in a circular manner. Communication satellite, they relays and amplifies radio telecommunication signals via transponders. The first man made satellite with radio transmission that was made in 1957. Currently, there are approximately 1071 artificial satellite orbiting in the that is the how much development we have done in case of this satellite system. Okay, this is what is actually a satellite, which moves in an orbit or in a particular path and around another particular thing. Early, the satellite TV viewers, they were explorers of sorts. They used their expensive dishes to discover the unique programming that wasn't necessarily intended for mass audiences. The dish and receiving equipment that gave viewers the tools to pick up a foreign stations also, live feeds between the different broadcasting station also. So the NASA activities and lot of other stuff was transmitted using the satellite system. Some satellite owners still seek out this sort of programming on their own, but today most of the satellite TV consumers, they get their programming through a direct broadcasting system, that is called as DBS providers such as Direct TV, Dish TV networks, etc. The providers, they select programs and broadcast them to subscribe as a set of package. Basically, the provider's goal is to bring dozens of even hundreds of channels to the television system of your that is at your home in a form that approximates the competition, that is cable TV. Unlike the earlier programming, the provider's broadcast is completely digital, which means that it has much better picture and sound quality than early TVs or analog televisions. Early satellite television, that was broadcast in C band radio, that is radio in 3.7 gigahertz to 6.4 gigahertz frequency range, that is C band radio station, 3.7 gigahertz to 6.4 gigahertz frequency range. The digital broadcast satellite transmits the programming in a KU frequency range. This KU frequency range is nothing but 11.7 gigahertz to 14.7 gigahertz. Now let's see the different components they are related to the satellite TV system. This block diagram or this diagram on the screen shows that what are the different elements or components they are present in a satellite system. Okay, let's see the different elements they are related to the digital TV satellite system. The elements in digital TV satellite system are programming sources. The next one is DBS provider broadcast centers, geostationary satellites, dish antennas, and TV receivers. Now let's see in detail each and every element that is present in this satellite system. The first one is programming source. The programming source, they are simply the channels that provide programming for the broadcasters. They provide the So the provider doesn't create original programming itself. It plays another company's, for example, HBO or ESPN, for the right to broadcast their content via the satellite. In this way, the provider is kind of like to broker between you and actual programming sources. That is, cable TV companies work on the same principle. Cable TVs receives the whatever data that is broadcasted by the different satellite channels, and that is taken by the cable TV under the right to get the content about that particular providers, and they provide that all the data that is transmitted or broadcasted by the different television channels towards you, that is the programming sources. The next element we can consider here is DBS provide broadcast center. The broadcast center, that is a central hub of a system at the broadcast center. The TV provider, they receives the signal from various programming sources and become a broadcast signal to satellite in geosynchronous orbits. The task of the DBS provider broadcast center is receiving the channel data, validating that particular data, then again they decode the original data, encoding and compressed by DBS provider. First they decode, then encode and compress. Compression is used here. Compression technique, they are using MPEG2 and MPEG4 because they are compressing audio data and video data, both the data. That's why two compressing techniques they are using here, and they send that particular data to the Indian geo satellites. This is the work that is done under the DBS provider broadcast centers. The next element we can consider here is geostationary satellites. What is geostationary satellites? These geostationary satellites are used for the transmitting that particular data that is we have processed at the broadcasting center, DBS broadcasting center. Whatever the data that is processed there, that is compressed, and whatever the work or whatever the task is done over the data, the output of that particular thing is transmitted using the geostationary satellite data. DBS provider satellite means whatever the data that is provided by the DBS, that is seen over the geostationary satellite by using this satellite. Then they adjust the frequency, different frequency for C band we have seen now, that is 4 to 6 gigahertz, and frequency for KU band, that is 12 to 18 gigahertz. These two bands they are using for the transmission of different frequencies, and they send that data to the provider's dish antenna. Whatever the dish antenna at the receiver station or at the cable's receiver station, that particular thing is, this data transmitted from geostationary satellite is transmitted towards that dish antenna hub. The next is dish antenna. Dish antenna is dish shaped type of parabolic antenna. As you can see in the image, the receiver, they receives the electromagnetic signals from the satellite. Whatever the signal that was transmitted from the geostationary satellite, that is received by this dish shaped type of parabolic antennas, and that is received here, and it is processed further for the purpose of showing that over a particular screen or TV. The receiver, the viewer's dish that pick up the signals from the satellite or multiple satellites in the same path of the sky, and they passes it on the receivers in the viewer's house. Whatever the television set that is at the viewer's house, at that place they send this particular data. The next element is TV receiver. TV receivers processes the signal and passes it on the standard television, a box-shaped device that converts a digital television signal to the analog for viewing on conventional set, or it enables cable or satellite televisions to be viewed. Means whatever the signal that was received by the dish antenna, dish picks that particular signal, that is transmitted towards the that television set at viewer's house. This television set, that is nothing but the TV receiver. We can call a television set as a TV receiver. That TV receiver catches that digital data and converts it into the analog form, so that the viewers or the clients, they can see, they can watch the particular analog video signals and listen the audio signals related to that. This is how the satellite television works. Now let us see the features of satellite television. These are some of the features that are enlisted here about the satellite television. It is having high definition television, simple user interface is there provided in the satellite television. Internal drive is also present in satellite television. Next feature of satellite television is remote management and playback system is available here. Digital video recorder system is also available. Means whenever you are not able to watch that particular broadcasting whatever the video that is broadcasting or whatever the program that is broadcasted, if you are not able to watch that, you can record that particular program and you can watch it later. detailed program information is also present over there. On the television set you can see detailed program information, that is when the program will be broadcasting, what will be the time of the broadcasting of the program, and everything related to that. Keyword search is also available here in satellite television, and you can have your favorite list also. You can list different favorite channels in the favorite list. These are the different features of a satellite television. Okay, getting the concepts of satellite television, what is exactly the satellite television and what are the different elements they are related to the satellite television, means how they work in different, how the different elements work for the broadcasting that particular program over a satellite television, and how that is received by the receiver's dish antenna, and features of the satellite television. Now let's move towards the working of the satellite television, means how actually the satellite television works, that we will see in detail now. Okay, let's start this point, the working of satellite television. Here in the satellite television, satellite TV programming, let us see how that particular satellite TV programming is done over here. Satellite TV providers, they get programming from two major sources. The sources are national turnaround channels, that is HBO, ESPN, CNN, etc. like that, and various local channels also, ABC, CBS, Fox, NBC, PBS, they affiliates in a particular area. These are the different national turnaround channels and some of the local channels. These are the two channels from this, the satellite TV providers get the programming from these channels. Most of the turnaround channel also provides the programming for cable television, and local channels typically broadcast their programming over the airways. The broadcast center that converts all of this programming into a high quality and compressed digital stream. It means that whatever the data that is transmitted from the two sources, that is national turnaround channel and local channels, the turnaround channels usually have a distribution center that becomes the programming to geosynchronous satellite. The broadcast center, they uses large satellite dishes to pick up these analogs and digital signals from different sources, so that they can get the data related to that and they can broadcast it over, or they can send it over there the users. Most local station, as we have seen, they don't transmit their programming to the satellite, so the providers has to get it another way. If the provider includes local programming in a particular area, it will have a small local facility consisting of few racks of communication equipment. The equipment receives local signal directly from the broadcast through the fiber optic cables or an antenna that then transmit them into the central broadcast centers. The broadcast centers then converts all of this programming into high quality and compressed digital stream, and at this point the stream that contains a vast quality of data, about 270 megabits per second, this much data is present in that particular stream for each channel. In order to transmit the signals from there, the broadcaster centers has to compress this particular data, which is having vast quality of data. So otherwise it would be too big for a satellite to handle that particular data, so that data is compressed here and then that data is transmitted. Okay, now let's see the satellite TV signals. The satellite TV signals have a pretty long path to follow before they appear on your TV screen in the form of your favorite television video, a television show. Means whatever you are watching on the television set, that is nothing but a satellite signal. Okay, that you have received at your television set, but it is actually a television signal that was transmitted there. That particular television signal have to go over a long path to be reached to your television set, because the satellite signal that contains such high quality digital data, it would be impossible to transmit that without the compression. That's why the compression technique we have to use for the purpose of compressing the data, that is large data that is transmitted by the broadcasting station and received by the different receivers. Here, the compression simply means that unnecessary or repetitive information that is removed from the signal before it is transmitted. The signal is reconstructed after the transmission. Means whatever the compression we have done in the signal, that is done at the transmitter, and after it is transmitted, it is we actually reconstruct the original signal which from which we have been compressed. Okay, this is how the particular satellite signal that is transmitted, that is compressed, and we reconstruct the original signal again after transmission. Now let us see what are the different standards of compression, because we have performed the compression process at the transmitter. So that let us see what are the standards of compression. The satellite TV uses a special type of video compression technique that is standardized by a moving picture expert group, that is MPEG. With MPEG compression, the provider is able to transmit significantly more channel. There are currently 5 of these MPEG standards, each serving a different purpose. Okay, that is MPEG 1, MPEG 2, MPEG 4 and MPEG 21. Okay, here DirecTV, Dish TV network, the two major satellite TV providers in the United States, once used MPEG 2, which is still used to store movies on DVDs, and for digital cable television, that is DTV. Now with MPEG 2, the TV providers can reduce the 270 Mbps stream to about 5 to 10 Mbps depending on the type of the program. This is how the compression technique is used, so that the memory needed for that particular data, that is being very less. Now DirecTV, Dish TV and networks uses MPEG 4 compression, because MPEG 4 was originally designed for streaming video in small screen like computers. It can encode more efficiently and provide greater bandwidth than MPEG 2. That's why MPEG 4 was morely used than the MPEG 2. MPEG 2 that remains the official standard for digital television compression, but it is better equipped to analyze the static images like those you see on a talk show or newscast, then moving dynamic images. MPEG 4 that can provide a better picture or dynamic images through uses of spatial, that is space, and a temporal time compression. This is why the satellite TV that is using MPEG 4 compression provides high definition of quickly moving objects that constantly changes plates and direction on the screen like a basketball game. Okay, in that way the video that is compressed in a proper way, so that whatever the match of that for example, whatever the match of that basketball game, that can be seen in a proper way in a good resolution. That's why MPEG 4 standard is being used there. Now let us discuss this all MPEG standards. The MPEG standard, they exist to promote system inappropriately among your computer, televisions and handheld video and audio devices also. The MPEG 1 is the original standard for encoding and decoding streaming videos and audio files also. Okay, this MPEG 1, this is original standard for encoding and decoding streaming video and audio files also. The MPEG 2 is the standard for digital televisions. First MPEG 1 was standard for the analog television. MPEG 2 is a standard form for the digital television. This compresses the files for transmission of high quality videos. Okay, in the digital television, high quality videos we are displaying over the television sets. That's why to display that particular high quality videos, MPEG 2 technique, MPEG 2 data compression technique is used for audio and video, both the purposes. The next MPEG 4 is the next standard for the compression. The MPEG 4 is the standard for compressing high definition videos into smaller scale files that streams to computer, cell phones and PDLs, that is personal digital assistants. That is the MPEG 4. Nowadays MPEG 4 is widely used for the purpose of better quality, better picture quality, better resolution and for better audio quality also. For the purpose of video and audio we are using MPEG 4 standard compression technique. The next standard compression technique is MPEG 21. This MPEG 21 is also referred to as multimedia framework, the standard that interprets what digital contents to provide to which individual user, so that the media they plays flawlessly under any language, machine or user condition. This is how MPG 1, 2, 4 and 21 is used for different purposes in different televisions. Okay, clear about the compression techniques. Now let's move to the next point, that is satellite TV encoding and encryption. How the encoding and encryption is done about the data over a satellite TV means, in the transmission we have used compression technique for the purpose of compressing that audio and video data. After that, when that particular data, compressed data, that is transmitted, we have to regain or reconstruct that particular original signal that was transmitted over the satellite. That's why we are using encoding and encryption technique for the purpose of regaining or reconstructing the original data. Here at the broadcast center, the high quality digital stream of video that goes through a MPEG encoder, which converts the programming to MPEG-4 video of the correct size and format for the satellite receiver in any house. Encoding that works in conjunction with the compression to analyze each video frame and eliminate the redundancy or relevant data and get the information from the other frames. This process reduces the overall size of the file, each frame that can be encoded in one of the three ways. Here we are using different three types or three frames for the purpose of compression of data. As an intra frame which contains the complete image data for that particular frame. This method provides the least compression. In the second frame, as a predicted frame which contains just enough information to tell the satellite receiver that how to display the frame based on mostly recently displayed intra-frame. Or predictive frame, a predicted frame that contains only data that explains how a picture has changed from the previous frame to next frame, means that is nothing but the next information regarding to that particular frame, how in the intra frame that particular data was displayed and how the particular data should be displayed, that is displayed in the predicted frame. That is nothing but the prediction. Next frame prediction is done in the predictive frame. Next frame we can consider is a bidirectional frame. As a bidirectional frame which displays information from the surrounding intra frame, okay, or predictor frame. Using data from the close surrounding frames, the receiver interpolates that position and color of each and every pixel and can predict the next frame. This process occasionally provides the artifacts or glitches in the video images. One artifact is macro blocking, in which the fluid picture temporarily dissolves into the blocks. Macro blocking is often mystically taken pixelating, a technically incorrect term which has been accepted as a slang for this annoying artifact. Graphical artists and video editors, they use the pixelating more accurately to refer to the distortions of an image. There really are pixels on your TV screen, but they are too small for your human eyes to perceive them individually. They are very tiny squares of video data that make up the image that you see on the television set. Now let us see what is the rate of compression. The rate of compression that depends on the nature of programming. If the encoder is converting a new cast, it can use lot more predictor frame because most of the scenes stays the same form on one frame to the next frame. In most fast paced programming, things they can change very quickly from one frame to the next frame. So the encoder that has to create in more intra frames. As a result of this, new cars generally compress to a smaller size than something like a car race. Now let's see what is the encryption. We have seen now encryption and encoding. What is actually the encryption and transmission of that particular compressed data? After the video that is compressed, a provider encrypts it to keep the people from accessing it for free. Okay, encryption scrambles the digital data in such a way that it can only be decrypted or converted back to its usable data form. If the receiver has the correct decryption algorithm and security keys, then and then only the particular receiver can decrypt that data that was encrypted at the transmission site. Once that particular signal is compressed and encrypted, the broadcast center they beams it directly to one of its satellites. Okay, the satellite pick up that signal with an onboard dish, amplifies the signal and uses another dish to beam the signal back to the earth where viewers can pick it back. Means originally it is sent towards the satellite receives that from one dish, then after reception sends it through the another dish towards the satellite, towards the earth, and so that the people here can receive that particular signal. Okay, getting the concept. Now let's move to the point that what will happen when the signal that was transmitted by the satellites towards the earth, that is received by the viewer's house, or that is received at the viewer's house by using the satellite dish antenna at the different people's house. The curved dish that reflects energy from the feed horn, that is generating a narrow beam. When the signal that reaches the viewer's house, it is captured by the satellite dish. A satellite dish is just a special kind of antenna that is designed to focus on a specific broadcast sources. The standard dish that consists of parabolic, or we can call it as a bowl shaped also, surface, and a central feed horn to transmit a signal to a controller, sends it through the horn, and dish focuses the signal into a relatively narrow beam. It means that we are having a feed horn and a bowl like structure which is called as a parabolic antenna. Here the feed horn that transmits the signal towards the controller, sends the signal through the horn, feed horn, towards that particular bowl like structure, and that bowl like structure or dish focuses the signal into relatively narrow beam, so that that is transmitted to the receiver station. The dish on the receiving end that can't transmit information, it can only receive it. The receiving dish works in an exact opposite way of the transmitter. When a beam that hits the curved dish, the parabolic shape reflects the radio signal that is inward onto a particular point, just like concave mirror focuses light onto a particular point. Let us see how the curved dish, that is bowl-like structure, focuses incoming radio waves onto the feed horn. In this case, the point is that the dish feed horn, which passes through the signal on the receiving equipment. In an ideal setup, there aren't any major obstacles between the satellite and the dish antenna, so the dish receives a clear signal because there are no obstacles in between that. In some systems, the dish needs to pick up a signal from two or more satellites at the same time. The satellites, they may be close enough together that a regular dish with a single horn can pick a signal from both the satellites. This particular thing compromise the quality somewhat, means receiving the both the satellite signals simultaneously at the same time. Because of that, the whatever the quality of the signal, that is compromised here, because the dish ain't aimed directly at one or more of the satellites. A new dish design that uses two or more horns to pick up a different satellite signal. As the beams from the different satellite hits the curved dish, they reflect at different angles, so that one beam hits one of the horns and another beam hits the different horns, so that the quality of the particular picture will not be compromised here. The central element in the feed horn is the low noise block down converter, okay, or we can call it as LNB. The LNB that amplifies the radio signal that is bouncing off the dish antenna and filters out the noise, removes the noise radio signals are not carrying the programming. In the LNB, that is low noise block down converter, it passes the amplified filtered signal to the satellite receivers inside the viewer's house, so that there will be no distortions in the particular signal and they will be able to watch the particular program in a good resolution and without noise or distortions. Now let us see the end component. The end component here in entire satellite television system is a receiver. Whatever the receiver, satellite receiver we are having at the receiver's end. The receiver have four essential works, or we can call it as a four essential jobs. What are that four essential jobs? We will see. It descrambles the encrypted signal. In order to unlock the signal, the receiver needs the proper decoder chip for the programming packages. The provider that can communicate with the chip via the satellite signal to make the necessary adjustment to for its decoding program. The provider, they may occasionally send the signals that disturbs the illegal descrambles as an electronic countermeasure ECM against the illegal users. This is how descrambling of the encrypted signal is done here. Next job of the satellite receiver is it takes the digital MPEG2 or MPEG4 signal and converts it into an analog format for a standard television that can recognize that particular format, because MPEG2 and MPEG4, by using this we are compressing the data. That's why for the purpose of receiving proper data, for the purpose of showing the proper data over the particular program user's house, that data to be converted into the analog format. In the United States, the receivers convert the digital signal to the analog national television system format. Some dishes and receiver setups can also output an HDTV signal also. Only NTSC signal is not given, they can give the HDTV signal also. The next job of this receiver is to extract the individual channels from the larger satellite signals. When any change, when you put anyone that changes the channel on the receiver, it sends just a signal for the channel to your television system. Since the receiver spits out only one channel at a time, you can't tape one program and watch the another. Okay, you also can't watch two different programs on your television set hooked up with the same receiver. In order to do this things which are standard on conventional cable, you need to buy an additional receiver so that you can have the two programs simultaneously, or you can watch the two signal programs simultaneously here. Okay, the next job for this receiver is to keep a track of pay-per-view program and periodically phones a computer at a provider's headquarters to communicate the billing information about the particular user. Receivers have a number of other features as well, as they pick up a programming schedule signal from providers and present this information in an on-screen programming guide. Many of the receivers have parental lookout options, and some have built-in digital video recorders also, which let you to pause live televisions and record it on the hard drive also, so that you can watch it later. These receiver features are just added bounces to the technology of the satellite TV. With its movie quality, picture and sound satellite television is becoming a popular investment for consumers. Digital cable television, which also have improved picture quality and extended the channel selection, it has proven to be the firecast competitors to the satellite provider. The TV war is ranging strong between the satellite and digital cable technologies, as well as between the providers who offer these services. Once considered luxurious in most households, the satellites and digital TV that are becoming quite common as a providers bundle TV with internet and phone services to offer competitive deals and win over the customers.